going to be having the next talk is going to be Arshan. He's the...
What's my last name?
It's D. Arshan D is going to be doing the presentation for building and stopping next generation XSS worms. So here you go.
All right, thank you. I'm going to walk. You got that nervous energy. Probably going to have the shaky voice too. All right, so my name is Arshan Dabirsiaghi. So like Mr. Miyagi plus Dabirsiaghi. I'm the Director of Research at Aspect Security. You can go to our booth if you want to find out more about us. But my job, not only to do the normal assurance work, but also to do research into what's coming next. Okay, so what I tried to do with this talk is figure out what were the hard limits, what were the upper bounds on what we could do with the Crosssite scripting worm with and without malware. So I didn't address malware as much as I wanted to because I realized that, with malware, all rules are off. It's just an engineering challenge in whatever you want to do to make the malware do whatever. Actually, before we get into it, I want to say something brief about clickjacking. So a lot of people wanted to hear about the clickjacking technique, including myself. And they pulled the talk because Adobe said that's really bad. We don't want that getting out. So after that talk, they leaked a few clues during their talk. And from those clues, I was able to figure out what the general technique was. And with a little more research, I figured out what one of the Flash problems would be, and I would rate the Flash vulnerability 7 out of 10. Okay, but the problem is that, and that would be bad enough, right? That Adobe would not want that pulled or wouldn't want that disclosed. But then I found out that there is actually a 10 out of 10 impact vulnerability with Flash. And I'm not going to give any details about it, but suffice to say that they have the goods. Okay, so if everybody remembers the Dan Kaminsky mess, Hal Flake was the one to first publicly, discover it, even though it had been discovered by other people, but quietly. And then Thomas, I'm going to butcher his name, Ptacek, P-T-A-C-E-K. He verified that Dan actually had the goods. So my impersonation is kind of them both. So I sort of figured out, one of the really bad things you can do, but they're sitting on something that's pretty much as bad as you can get. So I would definitely cut them some slack if you're upset about missing the talk, but really, really bad. Okay. So actually, just briefly, I just have it up on my browser. So people were confused exactly about clickjacking, what clickjacking is. And I want to point out that the code for doing clickjacking has been on RSnake's site under his Weird Labs section for about a year and a half. And Gareth Hayes, who's not as well known as he should be, he's a young hacker from the UK. He was doing something like this last year to iframe in and beat OpenID login forms. So this is something that is actually quite possible, and it's been done. So if the general technique of clickjacking is pretty well known, although we're calling it different things. So I'm going to move my browser over here, and that is huge. And it didn't work. Okay, so this is my site. You can't see it, I guess, because I have the opacity set too low for this bright screen. But basically, if you try to mouse over a link that's on the page, and I can't even see it. Okay, well, here we got another clue here. Okay, so we're on IEJesus, my site. Okay. And let's pretend that I put a link here with an absolute position with style sheets. If you actually click where my link is, it's going to go to netflix.com. So with this page, I can trick you into clicking an arbitrary link on an arbitrary site. So Netflix is something you're permanently logged into all the time. So if I iframe into an evil page, Netflix, and you come to my site, you're logged into Netflix, the iframe behind the page is what you're actually clicking into, and you don't realize it. I haven't weaponized this, but that's the general technique. Okay, so this is actually worse than the guys are willing to give credit for. I think it's pretty bad on its own. So there's, if you think about how to fix this, you come up kind of blank, because this is kind of an architectural thing built into the browsers. It's a feature, sure. So Web 2.0, DHTML, we got to be able to move stuff around, make it less visible. We need fade outs. So this is something that's built into the browser. The reason this is bad is not because I can trick you into clicking on one link, because most of the time you could do that with CSRF, right? So you would click on one link, and then we would drag the iframe to follow the mouse, and then we could have you click on a second link and a third link and whatever. If we can trick you into clicking 4 or 5 links, we can make you do pretty much whatever we want. Then all your token-based CSRF defenses are useless. Your refer-based defenses are useless because you're on the site. So, nothing looks broken. So what the browsers could do, I think, actually, is come up with a reliable frame breaker for iframes across browser. So if you could do that, then when you go to Netflix.com, Netflix.com can say, no, I want to be the top frame. And if I'm not the top frame, I'm not going to serve the request. So that seems to me to be the easiest way to do this, to apply this fix in the browser. But as it stands, kind of an architectural problem. How many people have frame breakers on their page? Yeah, very small number. Netflix is a big site, and they don't have a frame breaker. And even if they did, it's a little bit trickier to make that work in iframes, especially cross-browser. Okay, so I just want to, a lot of people gave Dan Kaminsky a lot of crap because they didn't know that he actually had the goods. So this is exactly the same thing. Those guys have the goods. All right, so we're going to get to the topic of my talk now that I wasted 10 minutes giving them press. Okay, so cross-site scripting worms. What we've seen so far in the cross-site scripting worm domain has been actually pretty elementary. I hate to say that, because I'm friends with Sammy, and Sammy wrote some really clever code, and he definitely jump-started our industry. We should all be donating to the Sammy Fund if he wasn't already like a millionaire, but he's doing okay. So we also owe Sammy, great round of applause, but Sammy was very, very non-malicious. And somebody who's got malicious plans can use cross-site scripting worms to do really, really awful stuff. So we're going to briefly look at worms in a kind of academic context, analyze what they're doing in the present, and figure out what can be different in the future. So Jose Nazario is the premier world expert on worms. So he did a lot of research for worms at the network level, with Code Red and all those other different worms that we had to deal with. So I want to apply his research to cross-site scripting worms and see what it yields. Okay, so he broke worms down into 5 components. You don't need all these components to have a worm, but to have it be a good worm and a long-lasting worm, you should apply as many of these techniques as possible. So reconnaissance, your worm needs to be able to find other nodes to infect. So this is possible with cross-site scripting worms because it's kind of a passive reconnaissance. If you infect a profile on MySpace and somebody comes to browse your profile, they're kind of coming to you. You're not really going to them. So whether or not it's real reconnaissance, we could debate, but the fact is we don't need it right now. So the attack component, we obviously have that. When somebody comes to view our page, we launch an attack against them. So that's taken care of. We'll give that a check. Communication. Nodes in the network must be able to communicate with each other. So one infected MySpace profile can't interact with another infected MySpace profile. There's no communication between them. You can't have HTML from one page talk to another, HTML from another page that, they have nothing to do with each other. They're not viewed in the same browser context. It's just not there, right? Browsers just can't talk to each other. Command and control. command and control is what makes worms really useful. Just infecting a bunch of machines is cool, but to actually have financial gain, you have to make them do something. So there is an idea of command and control right now in some worms, in some cross-site scripting worms that we've seen, and it's all based on this centralized theory of include the evil page. So like if I infect you with a cross-site scripting worm, I force you to go to evil.com and download the latest copy of the worm. Well, there's a couple problems with that, right? So if my worm gets big enough, I'm going to DOS the site. I'm going to overload it. It's trivial to call somebody at the ISP or the registrar and say, "Do you need to take that down? That's being used to propagate an cross-site scripting worm." It's just too easy to beat. It's a single point of failure. So we're going to try to do something about that. So it is possible right now, today, but it's just unreliable. Intelligence, the worm network needs to know the location of the nodes and characteristics about them. So this is what some of the network worms did, but cross-site scripting worms, we don't really see that in any of the worms that we've analyzed. So doing a little bit of fuzzy voodoo math, we come up with maybe 3 out of 5. So is a cross-site scripting worm is a worm a real worm according to definition? Probably. So how cross-site scripting worms are different from the network worm? The infection model is different. So the first thing to say about that is, how is a worm different from a virus? So a worm self-propagates over the network, okay? But I haven't thought this idea fully out yet, so don't hold me to anything here. But I have this idea that we can create a cross-site scripting virus. Okay, so we're passing around rich data in Web 2.0 everywhere. And rich data actually isn't data. Rich data is code. An image tag is code that your browser executes. Most cross-site scripting worms that we've seen don't need to be cross-site scripting worms at all. They can be CSRF worms. Okay? So your browser's executing this rich data that we pass around willy-nilly. So I have this idea that we can have a self-contained cross-site scripting virus, right? Because that's what makes a virus different from a worm. It's like it's attached to a file, executes in whatever context it's given safely, and reliably. But we haven't really done a lot of research into this yet, just something promising. Okay, so the infection model for a cross-site scripting worm is actually different from what you think it is. So there's the poor innocent girl on MySpace. She makes a request to MySpace. She looks at, Sammy's infected profile. She gets a response. You might think that, okay, now she becomes a worm node. This is actually like an abstract thing that you took with the data and made it out to be. She is not actually part of the worm network. So really, it's just that, there's some number out of all the profiles on MySpace that are worm nodes. So really what happens is when she goes to MySpace, she gets some payload delivered to her. That payload issues, XML HTTP request back to the site. And the whole attack is taking place within MySpace. Okay, so now it was n, but now it's n plus 1. Okay, so n plus 1 out of the however many profiles are now worm nodes. So the worm is strictly on MySpace, has nothing to do with the users. We're not owning the users at all. Okay, so let's see if we can change that in the next generation. So it requires user interaction. Okay, because the user needs to click on somebody's profile, right, or take some kind of action. So the worm's strictly contained with the web application. It's totally passive, totally localized. So no Warhol worms. Okay, so Warhol worm is a worm that's going to reach its maximum infection capacity in 15 minutes. So this was Andy Warhol's 15 minutes of fame thing. And one of the network worms did reach every machine it was going to reach in about that time. But we're not seeing that in the cross-site scripting worms. Orkut worm and the MySpace worm propagated very fast. Sammy had over 1 million friends in 18 hours. And that's a lot, but still 18 hours is a long time. Okay, the payload capability. The payload capability of a traditional network worm is any kind of malware that you want. Buffer overflow, format string, whatever, you can do any native code, right? But at the application layer, things are a little different. We can perform any application function, right? So if God help us, if our banks introduce any kind of social network capability, then you can, thank you, then they can, then, a cross-site scripting worm could transfer money, could do all the kinds of things that you can do normally with a bank. JavaScript in the browser is game over as far as the application. Okay, XSS proxy / attack API, so like any of the, XSS keyloggers or any of those kinds of cool things, like PDP's attack framework. So you can do that with a payload. So that's kind of like simulating malware. It's kind of like man in the proxy, or man in the browser, like Gunter was talking about. Totally JavaScript layer, though. Or we can direct the user to malware, and then the things are really bad. I mean, really, malware is just such a game changer. With any cross-site scripting where you can install malware to their computer and you have no more restrictions. You're only limited by your imagination. So it seems kind of silly sometimes to think about cross-site scripting worms and think about JavaScript when you just have to redirect them to malware and then you can do whatever you want. But I'm hoping one day that we'll figure out that if we have ASLR and we have stack cookies and we have non-executable heap, non-executable stack, and we combine all those things together into one thing, then we won't have this malware problem anymore. Okay, so let's think past hopefully that 2 or 3 years in the future when we have all those defenses in place. So the target shift. So traditional worms, like Code Red would go after IIS server, and then it would go after another IIS server, and it would jump from internet to internet. But when it landed on an internet site, it would actually do internal network address scanning so that it could actually hop behind your firewall, right? So this is not in a properly DMZ'd location, and we launch Code Red attack and attack something internal. Okay, so this technique is called island hopping. Okay, so we're hopping from an internet-facing island to a back island. So how are cross-site scripting worms different? Well, first of all, this is total ownage for an internet worm. Internet worm can go anywhere. And look at who we're going after. We're going after the servers. So lots of technical impact here, but not a whole lot of business impact. Okay, so how are things different for a cross-site scripting worm? So let's attach some names to these machines. So there's MySpace over there. MySpace has been hit with a cross-site scripting worm. LinkedIn, Facebook, some other social networks. So if we infect a user, multiple users, so we can own all our own users on MySpace with a cross-site scripting worm, the real goal here is to jump to another site. Right? Because we can affect 1 million users, but we want to affect everybody on the internet. Okay? So if we wanted to do that, we got to do things different. So this is where we're at right now. We'll come back to how things are different. Penetration. So if you hit a MySpace.com with the cross-site scripting worm, the MySpace worm can't just directly jump to Facebook. We can't trick MySpace into executing server-side code, right? So they can't jump to Facebook. So we need to figure out another channel. Okay, MySpace can't jump to Facebook users, right? Because it's server jumping to client. That doesn't make any sense. So that's also not possible. So we need to trick the user into going into Facebook and spreading the worm to Facebook. But because of the same origin policy, which works a lot of times and sometimes doesn't, that's not possible. I can't just fire up an XML HTTP request and start scanning and attacking Facebook. However, Billy Hoffman showed us with Jicto that we can use a third-party proxy like Google Translate to bounce and scan traffic to Facebook. Okay, so we can have a scanner through JavaScript using a third-party proxy. Okay, but this, again, is a single point of failure. So cross-site scripting worms need to be able to, if for the bad guys, cross-site scripting worms need to be able to be resistant to these centralized mechanisms, because centralization, I think I say later, is just another word for weakness in a worm. Okay, so we can scan that third party, but we have to use, or we can scan Facebook, we have to use that third party, so that's fine. So let's say we use that to own Facebook. We get their users. What I think is interesting and what I haven't heard a lot of people talk about is the fact that actually we can jump with a cross-site scripting worm from the outside internet to the inside internet using CSRF. Okay? So you might wonder, how come we can't use the same technique using a third-party proxy to jump to peoplesoft.internal? Well, it's because we can't jump to that third-party proxy because the third-party proxy does not have access to your internal web applications. Okay, so the only way, thanks to the same origin policy, that we can, send attacks to internal websites is through CSRF. And given the lack of security that people tend to put into internal applications, this doesn't seem far-fetched at all. Especially when looking at internal applications that are commonly used, like Documentum and some of these other things that are just riddled with problems. So a lot of us use the same internal apps, and it's not going to take me that long to come up with a JavaScript that does network, tries to send Documentum attacks against all the IPs in your network range. So it is possible to jump to internal networks. We can do that island hopping, but it's only going to be through CSRF. So right now it's kind of hard to jump across domain. We need that third-party proxy, and we can only island hop with CSRF. Okay, so it's my little burn on Tom Stracer. I meant to change that to netdev, but I didn't have time. So traits of the current worms: they're static, passive infection strategies, stay on the same domain. So there was one worm that jumped across domain. Actually, there was a couple. But the reason they were able to jump across domain is because the application took their application custom code took that message and sent it to another domain. That's not really jumping across domain. That's not reliable. It's only going to work for one site. So this Italian worm, Nuda, or however you want to say it, that did jump across different webmail providers, but again, it was programmed to, and same origin policy wasn't the restriction. So the same origin policy was never bypassed. Uncontrolled growth and no command and control. We did see one worm attempt to perform centralized command and control, but there was a typo in the URL, so they can never go get a copy of the new worm. Okay, current incident response. I know I'm all over the place, but I'm just trying to address every different question that you could possibly have. So current incident responses. Fix the vulnerability, obviously, if you want to do a patch. If we're dealing with a cross-site scripting worm when a minute is really valuable, again, 18 hours for Sammy's site meant 1 million users. We're talking minutes. We want to get this thing done in minutes. Sometimes, it's going to take hours to get a code patch through. Maybe a WAF is a good idea just for this reason. I'm not all about WAFs for everything, but this is one niche it seems that they could really fill pretty easily. So if you want to have a quick fix, do it with a WAF. Okay, manual purging. So actually, we worked with the client on Monday, right before I came up here, that got hit with a cross-site scripting attack, and they were trying to manually purge their database. It was really coincidental. I'd already built these slides and everything. It's just, it's very affirming to me that this happened. So they were trying to go through with 10 developers to go through their database and try to find all the instances of the cross-site scripting attack. So they had failed because there were a lot of things that they weren't looking at. It just doesn't scale, especially for a big site. So you could also try to revert your database to a snapshot before the cross-site scripting worm ever got there. But the problem with that is you lose all those other application changes, right? So you're not just reverting all the attack data, you're reverting everything that user or all your users has done in the last day. Search and destroy. Search and destroy kind of works now. So like Sammy's and everybody's all their attack payloads were exactly the same. So it's really easy to signature because it's exactly the same. So you can just do a for loop through the database and clean it out. So this is tricky, but possible if the attackers take the right approach. And we'll get more into that. Okay, the future. So we're going to go through the 5 components of the cross-site scripting worm and see how things can be different. Okay? Okay, so reconnaissance. This is about finding new network nodes to attack. And like I pointed out in my picture with the innocent girl in MySpace, with a traditional cross-site scripting worm, the girl is not actually involved in the attack very much. She just forwards an attack from MySpace onto MySpace. Okay? So how can we actually get the user to find new places to send the vulnerability or send the XSS attack? Okay, well, thanks to all the feature wars that are going on right now, we have a lot of options. So Google Gear's worker pool is a set of threads that you can use to kick off any kind of JavaScript in the background of an application. So we can actually run client-side code behind your browser kind of that you don't even know about. So Google Gears thread will live past when you navigate away from the page. So as long as your browser is open, we can kick off a scanner if we infect you with a cross-site scripting attack that will just live on until you close your browser. And sure, sometimes you're going to close your browser right away, but for as many people that do that, there are also going to be as many people that just leave it open, sometimes for days, especially with you Mac people, right? Because your Firefox is always alive, right? Okay, so it could be on for weeks, months even. Okay, HTML5 workers are, HTML5 is actually going to implement something that's like exactly like Google Gears worker pool. Okay, so we have that option, and then whatever tomorrow's new RIA is going to be. You can also do this with Flash. I mean, there's just like an unlimited amount of possibilities of how you can execute client-side code without them knowing about it. So what are we going to do in this code, in this thread, with this worker? We're going to be using this worker to go scan for more domains to infect. Okay, but what about the same origin policy? So the old and busted way to do it, I don't actually mean it's old and busted, right? It's actually still pretty cool, is to use Jicto or some technique like that with a third-party proxy. What what attackers should be doing now? They should be using malware, because malware changes everything. You can do anything you want with malware. But next generation hotness. Okay, so how are we going to jump into this next generation? How are we going to scan other sites or try to infect other sites? Okay, well, if you didn't know, you know now. XML HTTP request is going to become a cross-domain tool. Okay, so you're going to be able to send XML HTTP requests from one site to another and use ambient authentication, meaning your session cookies, your basic auth header, your client-side SSL certificate, anything else that's like ambient. So we've got that technique going for us. Cross-domain request in IE allows us in IE 8. That allows us to send cross-domain requests. That won't have the ambient authentication capability, but it'll still allow us to scan another site. Okay, so there's two techniques. And the third technique is called post message. So post message is an HTML5 spec that's already been built into the some of the major browsers. So it's not gonna not get here. In fact, it's already here. So post message allows one domain to talk to another domain through JavaScript API directly, no network communication. So if you want to do anything on the server to prevent this, sorry. Okay, so this is a little bit of a disaster. Oh, and let's forget about implementation vulnerabilities. So their design is already screwed up enough, right? But then there's all these, every time we do something like this, there's always implementation vulnerabilities. So don't even bother, all these great hackers, I'm sure there's not going to be anything wrong with it. Okay, so here's an email from Thomas Russler, who's kind of our contact at W3C for Owasp. And here's him saying post message is a terrible idea because the API of post message encourages developers to have terrible practices. Okay, so the way you send a message from one site to another is you send the origin that you want to send it to, the domain that you want to send it to, and you send it the message. And the message itself is a string. So what do you think a developer from Facebook and a developer from MySpace are going to do if they want to send structured data to each other and they have to use a string? How are they going to do that? Anybody? JSON. Yeah, JSON. So what is JSON? JSON is just JavaScript. Okay? So sites are going to be sending JavaScript to each other, and they're just going to be evaluating other people's JavaScript. Sound like a good idea? Absolutely not. Okay, so we've got shared security through XML HTTP request, and we've also got shared security through post message. So things are looking pretty bad. So of course the fix for this would be to allow the JavaScript, on the two different sides to be able to send structured data to each other rather than just a string, and they just don't seem to be listening to us. But we're working with them rather than opposed to them. This is one of the things we're doing with the intrinsic security working group, so we'll keep you updated. This is an example of using post message in a browser. So you add a listener for listening to messages. So you check the event.origin. And if and this is what you're supposed to do. You check to see if the origin is the origin you intended to receive it from. And if it's not, you're supposed to return. So guess what developers are going to do when in QA and dev the origins are different? They're either going to forget to implement those checks, or they're going to implement them wrong, or they're not going to even know about that they're supposed to do the checks. Okay, so we should have some kind of data binding approach where we can say this function receive message is bound to facebook.com. Okay, and then we can't have all this cross-origin craziness going on. But that's just not the design right now. But, the draft is not final, so we're still working. Okay, so, again, all that was just, we're still talking about how we can, what are the techniques we can use to go across domain. So there's also these well-known worm techniques for scanning. So hitless scanning. Hitless scanning is the idea that the initial growth stages of a worm are really slow. Okay, so in the first hour, Sammy only had, 25 people or something. So it's really slow during that first period. What if Sammy personally infected 50 profiles first? At the same time. By the 18 hours, he would have had everybody on MySpace. Okay, so that idea of you seed it 50 times, and then you kind of overcoming the initial slow growth rate, so you jump right to the exponential goodness. Okay, permutation scanning is another technique, meaning basically if the worm nodes have this way of automatically figuring out if a certain site's been scanned, and then it can go and do the next site. It's not going to duplicate effort. So this is something that's possible that worms aren't doing now. Topological scanning, not possible today, but going to be possible in the future. Okay, so the same techniques we have for sending reconnaissance, scanning other sites, we can use those same techniques to attack, to launch our attacks. So there's not really too much of a difference here. So the question becomes the likelihood that we can actually have a cross-domain jumping, cross-site scripting worm is directly tied to how likely it is you can find a store cross-site scripting attack in a black box scan. I personally couldn't tell you what the odds are because I don't work for a black box scanning company, but I have a feeling, at least their marketing people would tell you it's pretty possible. So I'm sure it's possible, but how possible is it? Even if we're looking at 5% of sites or 1% of sites, we're still talking about millions of sites out there. Okay? So as soon as we find one, we can push patches out to our worm, and I'm going to talk about how we're going to do that. Okay, so polymorphic JavaScript. Polymorphic JavaScript is this idea that we can take JavaScript and make it look like nothing it was supposed to look like. Okay, so then it becomes really hard to signature. Okay, so here we got a couple examples. Billy Hoffman is like the king of this stuff. He's like my hero. So you look at his research if you're interested in it. But basically the idea is we can obfuscate JavaScript so that it's hard from one profile to another to try to signature the attack. Okay, so if I wanted to clean up after a worm, it's difficult because the JavaScript in one profile looks nothing like the JavaScript in the next. But jump ahead real quick. No, I can't. Okay. So we'll come back to. There's a minor flaw in that argument. So I'm kind of summarizing, by the way, like popular debates we're having within the security, worm discussion community. So I'm trying to present all sides of this. Okay, so communication between worm nodes. How are two browsers going to communicate? I don't think they ever will, unless we have the stupidest plugin ever that could do it for us. And even if you could have node-to-node communication, there's no way to mutually authenticate. Like some of the work they did against the storm worm, which was a peer-to-peer worm, is the good guys sent messages that said, hey, self-destruct please, and the worm nodes were like, okay, self-destruct. Right? So to prevent that, you need mutual authentication. And there's no way to do that with two worm nodes. Okay? Because neither of them can be sure that the other is really a worm node and not a good guy. So command and control. Okay, so this is one of the cool things that I wanted to introduce today. So again, the old way of doing command and control that actually nobody ever even got to do was worm would call evil.js, okay, and then as the attacker found more and more vulnerabilities, he would bake them into this evil.js that he controlled. So as time went on, evil.js would be the latest and greatest copy of the worm. But again, there's problems with that centralization. So the problem I wanted to solve was, how can we make command and control structure without running into this problem of centralization? So I came up with distributed XSS worm node command and control structure, which is really too long and absurd of a title. Okay, so I forget what this slide is about. Okay, so this is the old way. We use remote scripting to a central place. So that's busted. Don't like that. So here's the scenario. The attacker goes out to all these different places on the web, and he quietly posts a bunch of signed JavaScript payloads. So yes, signing, encryption, all that complicated stuff is possible in JavaScript. People have actually done the work of implementing the algorithms. Okay, so attackers go out and they post those signed payloads all over the site, all over the internet. Okay, so then our central point of failure is Google. Okay, so then we use Google to search for some token. So the token could be base 64, today's date plus some secret. Okay, we don't care that other people discover the secret. So the victim queries Google for that token using JSON, because we can use remote scripting. So then all these different sites are going to come back in the search results. Okay, so these are the sites where we planted those signed payloads. So the good guys come and they try to poison us. Okay, they try to poison the results because that's what good guys do. But the problem is, when they try to send in a self-destruct message, the new victim is not going to execute the payload because it hasn't been signed by the attacker. The public key of the attacker is inside the JavaScript payload we gave to the first, to all the victims. Okay, so they can verify something that was, signed with the private key of the original worm author. Okay, so we have authentication. We have proof that the payload we're about to execute is actually coming from the worm author or the worm creator. Okay, so you might say, okay, well, we can get Google involved. Okay, well then I'll just use Yahoo, and I'll just hard code in 6 or 7 search engines that are going to allow me to do this thing. Okay, and when the worm looks up the results, you might say, okay, you could slow it down by making the first 100 results useless. Well, I'll just get random results between 1 and 1 million. So it would take a lot of work on the on Google's part to prevent this. And then even if they did put in that work, then I'm just going to use another search engine anyway. Okay? So maybe I'll use one from another country where it's going to be difficult for you to have influence over them. All right. So yeah, I got a link here for if you want to look at how they do all this encryption in JavaScript. Okay, intelligence. So Jeremiah is of the opinion that, and I think my boss was too, Jeff, that worms actually don't need to live that long. So Sammy's worm lived for 18 hours, right, and then it was taken down. I would like a worm to be able to stay up for days if I'm an attacker, right, as long as it possibly can. But the main financial purpose of an cross-site scripting world would be to deliver adware or malware or something. So if you can get 2 million people to install adware, guess what? That's a lot of money. Okay, so you don't really need it to be lasting that long. You just want to get a bunch of people, and then you can get out. So, in a more elegant solution would be to remain dormant and just spread quietly, and just not be noisy about it. But they don't seem to think you need to do that. I'm actually becoming inclined to agree with them. So first 24 hours reach massive infections through this epic growth rate, and then you're gone and never seen from again. So we still have code red traffic bouncing around our networks. I don't know if you know that. So who knows if they're really never seen again. Okay, so defense. So if you get hit with cross-site scripting worm, then again, you're probably going to want to do search and destroy, because you can't do the database snapshot restore because you're going to lose all your other application changes. So how do you search for all these different types of JavaScript that have been encoded and obfuscated in all these ways that Billy Hoffman talked about? Well, you can't. It's like impossible to signature that JavaScript. But the XSS vector itself is probably not going to be that different. Okay? So if my XSS vector for infecting your profile was style equals expression something, that's probably not going to change from profile to profile. We're going to need that to be the same. You know, even if we could find 5 cross-site scripting vulnerabilities on your site, it's only going to be 5 attack strings that we need to look for, despite how the payload of the attack string is encoded. Okay? Okay, so playing defense, if you're a social network, you need this kind of output filtering egress filter. Okay, so egress filter is something a WAF can do. I really actually don't even know what their capabilities for doing this are, but technically it can be done. So this is we discover quickly that we have a cross-site scripting worm going on because we have some pattern matching application level IDS where we can say, okay, well, we detect a substring being copied across a whole bunch of profiles. Okay, you have to have that if you're going to be a social networking site. So how about if we just set up a simple egress filter that commented out, a pivotal part of the attack string? Well, in this case, if we just comment this out, a 2-byte change, then the attack is never going to propagate because the attack code is going to be rendered inert. Okay, so we need this capability, these really agile response techniques. If MySpace had this in place, I mean, we probably never would have heard Sammy, right? He might have been spread for an hour and then never would have heard from him again. Okay, so that's very efficient. Anti-Sammy is an OWASP project that I lead with help from a lot of people. Jason Lee's helped a lot, Jerry Hoff with the .NET extension, and we've got people all over the world actually using this and helping to make it better. So we got a lot of small contributors all over the place. So if you want to be able to allow rich data in your site, but you don't want cross-site scripting attacks, you need anti-Sammy, okay? Or you need HTML Purifier if you're in PHP, which is it's a very good project. You need this capability, and Microsoft realized that it was such a great capability that they copied it, and they're going to put it into their anti-XSS library. And we've been in talks with them about doing that. We're going to try to make sure that they use the right approach, but it's going to be built into the .NET framework, so everybody's going to be able to have access to it. So that's pretty exciting. Okay, cross-domain workflows. Arsnake has a solution. So he did some consulting with one firm where they tried to use cross-domain workflows to protect against cross-site scripting attacks. So imagine this came out horrible. So imagine you're at Slashdot, okay, and you want to present some user content. So one easy way to protect yourself will be to have this iframe right here that points to untrusted.slashdot.org. Okay, so then the same origin policy today is going to protect us when malicious code gets in here, because the malicious code won't be able to affect anything else on the page. Right? So if you want to display a user profile, you just display that user profile in untrusted.myspace.com. But there's all kinds of usability issues, and search engines punish you for using iframes, and there's all kinds of other iframe usability problems. So people don't generally use this, but if you have maybe an internal application or you control the environment, maybe you can consider using some of these cross-domain workflows. Content restrictions. Okay, people have pretty much given up on content restrictions. The idea of content restrictions is we can set up some kind of jail in the HTML markup where anything that goes between it gets neutered of any active content. Kind of like NoScript, right? How many people use NoScript? Okay, you should all turn on NoScript, by the way, for the clickjacking attack. If you have NoScript enabled, I can't perceive any attack working against you. So anyway, so imagine like if NoScript looked at this tag, found this tag, and anything between it is stripped it out. This is something that's capable of doing now, and in fact, we're talking about maybe doing it. So that would be, that's pretty much what we want. We want to be able to have different policies on what can happen for code executing in different parts of the page. So if we have thief book over there, that's going to be severely limited in what it can do. But code that's in this other part of the page is allowed to do whatever it wants. So this is pretty much what the Java security policy is, right? You can set up policy files in Java to allow as fine-grained control as you want, but nobody uses it because it's too hard. Okay, but Facebook could spend a few days coming up with a strict policy file for JavaScript if there was such a thing, and they can build a really nice policy file to protect their users. but there's no technology to do it right now. So I have some ideas on what it should be, how the format of it should be, but we're still early in this talk. Okay, that's my talk. So I think I solved some of the problems with having a cross-site scripting worm that can jump across domain and can have a reliable command and control structure. And I also wanted to represent the discussion about cross-site scripting worms in a more academic context, because the work that Jose and Nazario did to frame it was really good, and we should be working within that framework. So if anybody has any questions. Not one, huh? Not one? Somebody throw me a pity question. Oh. I'm sorry, what was that?
Here.
Will you be publishing a more academic treatment of this?
I have a paper that I wrote that was peer reviewed and accepted for Owasp Belgium. When I first presented this research in May or March, whenever it was when we were all in Belgium. So there is a 25-page academic style PDF that discusses pretty much everything here. So, and I have built some of the pieces of this worm. Of course, I'm not going to release it, and of course, I haven't put it all together. And, there's still pretty big pieces that I'm missing because, of course, we're waiting for the browsers to implement some of the features that they say they're going to implement in the drafts. But there's really nothing stopping a lot of people from carrying this kind of attack. I talked about defense, Eric, before you say anything.
This is a pity question. So, how long do you think it's going to take before these next generation techniques that you've been talking about actually come to fruition? Like, when are we going to see these active?
So that's a very interesting question. If everybody knows about Slackers, Slackers is a forum that RSnake hosts. Everybody in Slackers is about 6 to 8 months ahead of everybody else. Okay, so that's just like a collection of 16-year-olds that just like think about this stuff all day long because they have nothing better to do, and they're really like way ahead of the game. So realistically, I think everybody's limited by when the browser is going to implement some of these features. But with some of today's technology, we can still accomplish a lot of these techniques, including the distributed command and control that's reliable and authenticatable. Will we see it? I don't know. It seems like there's not as many black hats out there as some of the marketing people would like you to believe, but they're out there, and it seems like it's kind of a chance thing. It's like they may choose to do it, they may not. It depends on how bored they are, or if they have a good connection with a malware or adware company. I don't know.
Any more questions? All right, thank you guys so much. Okay, everyone, we'll be getting